Hello dear, how are you all? Today we learn about an increasing function, decreasing function, turning point and about its nature. How can you find turning point? How can you decide whether turning point is a maximum or minimum? How can you find the interval for which given function is increasing or decreasing? Today I will try my best to explain you each and everything about all these with full concept. Before to start, we have to learn when a line has negative or positive gradient. If a line makes an acute angle with a horizontal axis, its gradient will be positive and the shape of line as shown in figure will be like this. And if the line makes obtuse angle which is greater than right angle, its gradient will be negative and the shape of line will be like this. Let's talk now about an increasing function. Consider a function y is equal to f of x. Y is equal to f of x defined in a closed interval a or b. Here, if for each x1, x2 some point belong to a or b, if for each x1, x2 belong to a or b, f of x2 greater than f of x1 when x2 greater than x1. We consider a function y equal to x defined in a closed interval a to b. If for each x1, x2 belong to a b, f of x2 greater than f of x1 whenever x2 greater than x1. In this case, function is said to be an increasing function. To explain this, we draw a graph of a function by taking some points with their ordinates on it. Here is the x-axis and y-axis. We draw a graph by taking some point on it with their coordinates. This is a graph of a curve. We take some point with their ordinates. Here x is equal to 1, x1, x1, x2 and its coordinate. Again we take x3 with its coordinate this. Now when we move very slowly along the curve from x1 to greater value of x1, I mean to say when we move from right side of x-axis, we say that x is equal to a, to x is equal to b. We observe at each point of the curve both x and y coordinate will change. Both x and y coordinate will change. As x coordinate is increases, y coordinate is also increases. We can say that for each greater value of x, its ordinate or its image will also greater. One thing more come in our observation, that for an interval a to b, when we draw a tangent at each of the point belong to this interval, its gradient will be positive. Here we can simply define a function f of x is said to be an increasing function if f prime x greater than 0 for all x belong to A or B. Similarly, if for each x1, x2 belong to A or B, f of x2 less than f of x1 when x2 greater than x1. In this case, function is said to be decreasing, and to understand this, we again draw a curve by taking some point on it. We draw again curve. Now it is a graph of a curve. We take some point on it. This is x1 and its ordinate as shown in figure. This is x2 and the value of x, and we take other point x3 and its ordinate as shown in figure. It is clear from figure, as we move toward right of x-axis, I mean to say when we move from smaller value of x to greater value of x, the value of y continuously decreases. Moreover, for the interval AB, when we draw a tangent at each of the point belong to this interval, its gradient will be negative. Here we can say that a function f of x is said to be decreasing if f prime x less than 0 for all x belong to A or B. And to find the interval for which given function is decreasing, we just solve inequality f prime x less than 0. Let's try to this by taking an equation of particular curve. We consider a curve y is equal to x square minus 2x plus 3. We try to understand the concept of increasing or decreasing function by taking an equation of particular curve. We say that y is equal to x square minus 2x plus 3. We just draw the graph of its curve and try to understand where it is increasing and where it is decreasing. From the equation of curve, it is clear that it is not symmetric about any axis. Curve is not symmetric about any axis. Origin doesn't lie on the curve, and there are no x and y intercept. To find turning point, we just equate first order derivative to 0. Here dy by dx differentiating by x, 2x minus 2. We put first order derivative dy by dx equal to 0 to find turning point, and turning point are the point where when we draw tangent, and tangent will become parallel to x-axis. This implies 2x minus 2 is equal to 0. We get 2x equal to 2, x equal to 1. When x equal to 1, y becomes 2 from this equation. We replace x equal to 1 in this equation to find y coordinate. Here 1 or 2 is a turning point. Turning point is a point on the curve when we draw a tangent on this point. Tangent will become parallel to x-axis. We now take some point to plot the curve. Here table value, when x is 0, y is equal to 3. When x is equal to 1, y becomes 2, and when x equal to 2, y becomes 3. When x equal to 3, y becomes 6, and when x equal to -1, y again becomes 6. We now just draw the curve. X 1, 2, 3, so on. Y is 1, 2, 3, 4, 5, 6, and so on. X is equal to -1, -2, -3, and so on. First we plot its turning point, which is 1, 2. When x is equal to 1, y is equal to 2. This is a point where when you draw tangent will become parallel to x-axis. It is a turning point. And when x is equal to 2, y is equal to 3, it means here is a point. And when x is equal to 3, y becomes 6, this is a point. When x is equal to -1, y again -6, this is the point. We now draw this is a turning point 1 or 2. Now it is clear from figure for each x greater than 1, the value of y continuously increases. For x greater than 1, values of y continuously increases. And we can see that when we draw tangent at each of the point for x greater than 1, its gradient will be positive. We simply can say that function is increasing for the interval when x greater than 1. Similarly, we can see that when x is less than 1, the values of y, which are like these, I mean to say, when we move toward the right of x-axis, the values of y continuously decreases, and when we draw the tangent at any one of the points, its gradient will be negative. We can say that function is decreasing for the interval when x is less than 1. We will now discuss about the turning point. A curve has many points on it. The points on which, when we draw tangent parallel to x-axis, are called turning point. To find turning point, we just equate first order derivative to 0, and when we find the values of x, to find y coordinate, put these values of x in a given equation. There are two methods by which we find the nature of turning point. In first method, we just find first order derivative dy by dx. Suppose we have to check the nature of the turning point x is equal to a. We take 2 points before a and after a, which are very closest to a. Suppose if the value of first order derivative at smaller point is positive, and the value of and the sign of first order derivative at greater point is negative, we say that that point is a maximum turning point, because result is changed from positive to negative. I mean to say that when at lower point the sign of first order derivative is positive, and if the sign of first order derivative at greater point will become negative, result is changed from positive to negative, that turning point is said to be a maximum turning point. Similarly, if the sign of the first order derivative at smaller value of x is negative, and the sign of the first order derivative at greater point is positive, we will say that turning point is a minimum turning point. In second method, which is very simple, we find second order derivative. We differentiate two times and we put the turning point, that is which is to be checked in second order derivative. If the sign of the second order derivative is positive, we say that turning point is the minimum turning point. And if the sign of the second order derivative will become negative by putting that turning point, we say that turning point is a maximum turning point. This is the way to check the nature of the turning point. And we have discussed about when a function is decreasing, when increasing, and when it's above, and we studied that about its nature.